Hello and welcome to Talk of Today, where we explore developments in science, technology and society, and what they could mean for the future. Today we are talking about climate change and the precarious position we are all in, threatened with the very collapse of our societies and the biosphere upon which they all rest. All of this due to our inaction. Joining me to explore this sobering topic is Earth System scientist Professor Will Steffen. Will is a climate change expert and researcher at the Australian National University in Canberra. He's held many positions related to guiding our species back onto a sustainable climate trajectory. He was the executive director of the Australian National University's Climate Change Institute. He served as a science advisor to the Australian Department of Climate Change and Energy Efficiency. He was a founding climate councillor of Australia's Climate Council, and he has been an author and reviewer of 5 of the IPCC assessments and special reports between the years 2000 and 2018, where IPCC stands for the Intergovernmental Panel on Climate Change. So in our conversation, we cover how bad the current situation really is, the tipping points which we are at risk of transgressing or might have already crossed, the difficulty of modelling a system as complex as our climate, and thus the need for a great deal of humility and caution when dealing with climate change. We also talk of the threat of social collapse due to climate change and why we really need to get our act together by 2030 in order to try and stabilize the climate system. And without further ado, please enjoy my conversation with Professor Will Steffen. Will, great to have you here. If you could just begin by just introducing yourself and the work that you've been up to over the past few decades, and what you're currently doing today.
Yeah, well, my basic area of interest is what's nowadays called Earth System science, and I got into that well over 30 years ago with the formation of a big international program called the International Geosphere Biosphere Program, which is rather a mouthful scientifically, but you can think of it more easily as a study of global change. I was based here in Canberra at CSIRO at the time, but Canberra was the headquarters for global effort on the terrestrial ecosystems, the land-based systems component of that big international program. And that got me started. And then I went on from there to become the director of the entire program in 1998, which was 8 years later. And I moved to Stockholm, Sweden, and spent about 7 years in Stockholm in that position, and then came back down, joined ANU, but have continued developing this theme of the Earth as a single system. How does this system work? How are humans influencing this system? And what sort of futures might we face?
Yeah, can you shed some light on how the system of Earth as a whole functions? How does energy flow through it, and how has this been changing, and is it changing due to man-made climate change?
Well, the idea is that the Earth operates as a single system at the planetary scale, and that system comprises traditionally 2 parts: the non-living part, the atmosphere, the ice, the rock, and so on, the so-called geosphere. But then what makes Earth really interesting is that it has life. It has a biosphere, which are plants, animals, and so on. But the interesting thing on Earth system science is these 2 are intertwined very closely. They influence one another. Their interactions form a single system. Energy flows through this primarily from the sun. So it's solar energy which drives the Earth system, and occasionally it gets interrupted by energy from down underneath the Earth system, which are volcanoes and plate tectonics and things like that. So you can think of the Earth system as being sort of the skin of the planet, the land down to where plants, their roots go, the oceans down to the bottom of the ocean basins where there is still life, and so on. And of course, then we have the core, which is usually not considered part of the Earth system. So you're right, the whole system is driven by energy flow. And of course, the one we're really worried about now is the interaction between the solar radiation, which keeps Earth going, and the fact that human activities are now changing the balance of that incoming and outgoing radiation.
So can you give me an idea of the scale of, so I understand that, we have ocean currents, for instance, that just transmit huge volumes of water across the planet. And these flows obviously carry lots of energy because they have a certain temperature. And this is just one example of how energy is flowing across the planet. How much energy is being currently, I guess, transferred throughout the planet due to these what would you say, these non-biotic systems? And yeah, we'll just go from there.
Yeah, well, normally Earth is in balance. So the amount of energy that the sun pours onto the Earth through solar radiation is equivalent to the amount of energy that the Earth releases, mainly through heat. And that has to be so, otherwise the Earth would heat up and burn up. And it's been around for 4.5 billion years and hasn't done that. And so we can actually measure this. And what you're referring to is the internal redistribution of heat. And that goes on between the land, the ocean. The oceans are hugely important, the ice, and the atmosphere. But those adjust the heat around the planet. But the overall balance is the incoming solar radiation, which is what we call shortwave radiation, and the outgoing radiation back to space, which is in the form of heat, which is long-wave radiation. So there are different types of energy. And, of course, that's where the whole climate change issue comes in, because what we're doing is, of course, we don't really affect very much how much solar energy is coming in, but we can influence how much heat is going out by changing the composition of the atmosphere, because that filters, if you like, in a very crude way, the amount of heat that's going out to the outer space, out of the atmosphere.
Mm-hmm. Can changes to, let's say, the melting ice caps, can that actually change the direction of these ocean currents? And if so, what sort of implications could that have for terrestrial life forms?
Yeah, that's a really good question. Yes, they can influence ocean currents, and it works this way, is that ocean currents, sometimes called thermo-haline circulation, thermo meaning differences in heat can affect the circulation, haline meaning differences in salinity, the salt content of the ocean, can also affect the circulation patterns and speed. So basically what happens is when you start melting ice at the poles, what is happening now primarily at the North Pole, which is heating about twice the global average. For example, Greenland, where ice melt is accelerating, that pours fresh water on top of the North Atlantic Ocean. So we're developing a large pool of cold fresh water at about 0 degrees Celsius. But that then sits on top of the ocean, changes the density distribution down through the surface waters of the ocean, and ultimately affects the circulation patterns, because you need to have dense saline water at the surface, which then can sink and sort of drive a conveyor belt. And when you put fresh water over the top, you're slowing that conveyor belt of water sinking, going down the bottom of the ocean, arising, and coming back around. Like it's a big circulation belt like that. So basically, the upshot of this is we can already measure a slowdown of the Atlantic north-south circulation. And we're pretty confident that slowdown is due to the melting of ice from the warming climate and all that fresh water coming onto the surface. And of course, that has lots of implications around the planet. One of the most important ones is that is reducing rainfall over the Amazon forest, because that depends on Atlantic Ocean surface circulation to provide water vapor, which then goes in over the Amazon basin and falls as rain. But as that ocean circulation slows down, rainfall is dropping off in the Amazon, leading to increased drought and increasing the risk of fires and loss of carbon from that forest. So that's a good example of how this whole system works. So ice connects ocean, connects rainfall, connects land.
And land, food, just life.
Ecosystems, biodiversity, indeed, that's right.
Yeah.
So this is why we say the Earth is one system that is connected.
Yeah. Talk of climate change is everywhere, and I think it's worth just cutting to the chase and going into how bad is it? Like, what's the situation at the moment? What do we need to do? What are the consequences of inaction? How bad is the current situation?
That's a huge question. I would say that the students are correct. The students who are out there protesting and saying we are in a climate emergency, I think we are in an emergency. And the reason I say that is there is growing evidence that already at a 1.5 degree rise in global average temperature, we're entering dangerous territory. We already are in a way at 1.1 or 1.2, depending on how you define pre-industrial. Even at this level, as we've seen here in Australia in 2019, 2020 with the bushfires, but in other parts of the world, they've had fires, they've had increasing tropical cyclones, increasingly intense tropical cyclones, higher sea levels, that's causing more damage to coastal areas and so on. The list could go on. So what I'm saying is even at a 1.1 or 1.2 rise, the impacts, the risks are getting quite serious. Once you go above 1.5 toward 2, those risks escalate, and it's what we call a non-linear process. In other words, it just doesn't scale, saying that the risks at 2 degrees are twice as bad as 1. They're actually much more than twice as bad as 1. So it's an escalating risk profile. Mm-hmm. So the problem is we are already committed to transgressing 1.5. We're sitting at 1.1 or 1.2. But the momentum in the system, the climate system, it's not in equilibrium yet. By the time the ocean and atmosphere re-equilibrate, we're going to get another 2 or 3/10 of a degree on top of that, on top of where we are today. And of course, we can't get emissions to zero tomorrow. It's going to take us several decades at best. So you put all that together, we're going to breach 1.5, probably sometime between 2030 and 2035. We're getting into increasingly dangerous territory. Now, here's why I think it's an emergency. The hotter it gets, the more likely we are to hit these tipping points in the Earth system. That is, once Greenland starts melting at a certain rate and its elevation starts lowering because it's melting ice on top, it's moving into a warmer climatic zone, which increases the melting, which lowers it even faster. And once you get to a certain point, that is basically irreversible. Same thing in a different way, though, with the Amazon forest. Once you get a certain level of drought and increasing fire, that is going to make the rainforest non-viable. In other words, it's going to be replaced at its edges by ecosystems which are fire tolerant. They'll burn more often, eat into the Amazon rainforest, which creates even more fire tolerant savanna ecosystems or woodlands, and the whole process just takes on. So there are a number of these around the planet that we can identify. We think that there are several key ones that are vulnerable between 1.5 and 2 or a bit above 2. Once you start tipping those, they act like a row of dominoes, and one will tip another. And there could be a point beyond which we simply lose control of the system. And it's going to go to a much hotter state no matter what we do with our own emissions. So this is why I think the students are right, that we are at the beginning of a very, very risky trajectory of the Earth system. And we are indeed in an emergency.
Mm. And these tipping points, they may not just be triggered at, 3 degrees or whatever. Like, we may be at risk of transgressing these lines right now. Is that correct?
Yeah. For example, coral reefs. There's a tipping point for coral reefs. They can tolerate temperature rise up to a point. And once you go just a few tenths of a degree above that, they start bleaching. It's very widespread. The Great Barrier Reef has had 3 of these mass bleaching events in the last 5 years, 2016, 2017. And
just for clarification, what exactly is a bleaching event?
A bleaching event is where the hard corals on the reef, that's the corals that you see, the staghorns and plates and all this, beautifully colored corals, they get too hot and they spit out their zooxanthellae, which are little organisms which have a symbiotic relations with the coral. They live inside the coral, they give it their color, they provide nutrients and food for the coral, and so on, and the coral provides them with a safe home. So it's a symbiotic relationship. But when it gets too hot, the corals themselves get stressed, they spit out their zooxanthellae, they lose their color. Now, if that's an isolated event and the water cools, they can recover, and the zooxanthellae will repopulate the corals. But if they get bleached too often, or if the bleaching is too severe, then the corals themselves die. And then they are permanently white, bleached, They start cracking up and eroding as waves come in and so on. So we can say now that I think close to 50% of the Great Barrier Reef is basically dead. These corals aren't just bleached, they're dead. So that's a huge change to this 2,300 kilometer long reef. Now, this is at a 1.1 degree temperature rise in global average temperature. That means that by 1.5, the IPCC suggests that somewhere between 70 to 90% of corals will be dead. That's at 1.5, which we're committed to. At 2 degrees, which I think is going to be very hard to avoid, they say 99%. Basically, coral reefs are gone, as we know them. So I think there's a death warrant hanging over the Great Barrier Reef and other coral reefs because we haven't acted fast enough on climate change.
And what are the implications of dead reefs? What benefits do they provide to the ecosystems and the communities that live near them?
Well, of course, they are the structural elements that provide the environment for all the other creatures that live there. Hugely diverse, I think the most biodiverse ecosystem in the ocean. And of course, once that structure is gone, there's going to be a much simpler ecosystem. We can see that already on sections of the reef that have been bleached. They get covered by algae. Many of the fish leave. It's a much simpler and less attractive ecosystem, less complex ecosystem as well. So that's what the future looks like, unfortunately, for the world's coral reefs.
So that's one example of a tipping point. Could you? What are some others that we are close to broaching, or could do so within another degree or so of warming?
I think the one that we may be very, very close to tipping is the Arctic sea ice in the northern hemisphere. So this is floating ice on the surface of the Arctic Ocean. It's not on land. And in the northern hemisphere summer, when it's sunlight 24 hours a day, of course, this ice gets a lot of solar radiation. But on top of that, the temperature in the north is warming at twice the global average. So they're already over 2 degrees Celsius temperature rise. Yeah. So what that means is during the northern hemisphere summer, this floating white ice is shrinking. So that is reflecting less sunlight, and there is more dark ocean now being uncovered that absorbs sunlight. That intensifies the warming in that region. So here you have a feedback mechanism that the more that shrinks, the more dark ocean is exposed. The hotter it gets in the region, the more the ice shrinks, the more ocean is exposed, and you hit a point at which it becomes unstoppable. We think we're close to that, and maybe within the next decade or so, that will probably be tipped. And of course, that has implications for Greenland, because the Greenland ice sheet, which sits on land and is equivalent to about 7 meters of sea level rise, then experiences much hotter conditions because now you have an open, dark ocean during the summertime up in the north.
Yeah. So when you hear about temperature rise and you hear like 1 degree, 2 degrees, it doesn't sound as bad as the implications really are. You think like, well, what would 1 degree hotter mean for me? Well, 23 degrees to 24 degrees, or 32 to 33. But that's the global average, right? That's not representative of what the days that we are going to experience like. So perhaps you could just tell me a bit about the sorts of days that we could be experiencing here in Australia and around the world with levels of temperature rise at, let's say 2 degrees, 3 degrees, and perhaps even this hothouse Earth scenario that we might be traveling towards.
Right. Yeah, look, that's a very good point, is that this 1 degree or 2 degrees is global average temperature. So it's averaged about a meter and a half, I think, above the Earth's surface over land, ocean, everywhere. But what that means is when you translate it into, for example, maximum temperatures, they go up at a much greater rate than the average. So here in Canberra, for example, on average, we would get, before climate really started shifting, maybe 5, maybe 7 or 8 days during the summer, which were over 35 degrees. We're a pretty cool place by Australian standards. Now we're routinely getting over 30 days, over a month's worth of temperatures over 35. And we're hitting temperatures over 40. Some summers we hit temperatures 42, 43. I think we've even hit 44, which was unheard of pre-climate change. Penrith, to the west of central Sydney, was the hottest place on Earth for a day. I think that was in 2019, 54, 55 degrees Celsius in Penrith. Now, that's what you're seeing with a 1 to 1.1 degree rise in global average temperature. So it makes a very big difference for maximum temperatures or extreme heat and so on. If you look at a 2 or say a 3 degree rise in global average temperature, some of the projections say that a large part of the Australian continent will be uninhabitable. It'll simply be too hot for Homo sapiens to inhabit.
So a lot of Australia is somewhat uninhabitable, right? That's the way I think about it. We have this, huge desert that not too many people live in. So are we talking about coastal areas or places that are just a few hours inland that will be uninhabitable?
Yes. So we're talking about large areas of the interior. It's probably not quite right, maybe uninhabitable for Europeans, but Indigenous Australians have learned how to live on this continent in all places. But it is true to say that at the time of the European invasion, most Indigenous people were exactly where we are, which is along the eastern coast. But nevertheless, there were significant populations right throughout the country. But what that means is that we think of the western deserts or the central deserts as being the Simpson Desert or out around Uluru and Katajuta and so on. But what it means is if we go to 3 degrees, a lot of that's going to be really extending. So western New South Wales, which we consider habitable, there's agriculture there, there is grazing there are townships, regional centers. Areas like that will become largely uninhabitable. It'll be too hot for humans unless you spend all your time in an air-conditioned indoor place, artificial environment. So that's what we're saying is that the areas that are already hot for Australia are going to be spreading out toward the coasts. The coast, of course, and we are largely a coastal country, the coasts are not immune from the effects of climate change, and that'll take the form of rising sea level, which is going to go on for centuries. That's already locked into the ocean ice.
So centuries of rising sea levels is locked in.
Absolutely. Yep. But the rate at which that occurs still is somewhat under our control. If we get emissions down, that will be important because it will slow the rate and allow us to adapt. But if we keep with high emissions, we could get rates up to 1 meter a century, which in geological terms are exceptionally fast rates. And when you start thinking about our infrastructure, if we want our infrastructure around for 50 to 100 years, which is what we want some of our infrastructure to that's their lifetime, then you got to plan out and say, if you're within 1 meter or even a couple of meters of mean sea level rise, you may not want to put your infrastructure there. But the real damage gets done not by the long-term average sea level rise, but by high sea level events. And by that, we mean a high tide coupled with a storm surge and could be driven by increasingly powerful storms, east coast lows, cyclones off the coast. But when they're riding on a higher sea level, they penetrate further in and do damage much further in. So that's really what the coast, I think the big issue for the coast is going to be rising sea level, more intense storm surges, and in some cases coupled with more extreme rainfall along the coast, say the northern Queensland coast. And that double whammy means you're going to get a lot more water from inland at the same time you getting water from the sea, which is a very dangerous situation.
So one day we'll have temperatures at about 50, and the next day we'll have catastrophic flooding. Like that's a.
I don't know if I'm happening day after day, but yeah. I would say that one summer you may get many more areas of Australia with 50-degree temperatures. That is with a 3-degree rise in global average temperature, and then you may say a year or two down the track you could get a really vicious storm off the North Queensland coast, driving in a wall of water that's going to do a lot of damage.
So that's Australia. What about other parts of the world? What sort of changes can we expect in, let's say India or Canada? How will their climates, how could they change?
If you look at Canada, Canada's in the far north. And so the northern part of Canada, which is covered by forest, so-called boreal forest, mainly spruce, pine, that type of needle-leaf forest, they're going to experience temperature rises that are more than the global average because they're in the northern, high northern latitudes. And that's a general feature of climate change. Already what we're seeing from the rising temperatures there is that there's an increased infestation of insects, bark beetles in particular, and that's because the life cycle of the bark beetle normally took 2 years for it to reproduce. Now, because the temperature is much higher, they can reproduce in 1 year. The populations are exploding. They're attacking the trees much more vigorously. That's weakening the trees, and that's making them more prone to burn. You're getting more fires, which puts more CO2 in the atmosphere, so you get a feedback going there. So that's one of the things that's happening both there and in Siberia, is an increase in boreal forest fires and dieback. So that's one thing that's going to happen to Canada. In terms of, what was the other place you were?
I said India, but I'm just like India.
Right. So India is going to be affected in a couple of ways. I think the coastal issues there are hugely important. They have many big cities that are near the coast. Mumbai and Kolkata come to mind immediately. But if you look at their neighbor Bangladesh, which is facing the same sort of impacts of climate change, already what's happening in Bangladesh is because of sea level rise, saltwater intrusion in the delta. That is knocking out rice farms because the roots now of the rice crop are in saline water. Rice crops fail, and that puts stress on the food systems, also puts direct stress on humans because farmers in the delta, the Ganges Delta, then have to move north. They go into Dhaka. They can't find jobs. Rising unemployment in Dhaka, more social issues. And you can see the sort of social reverberations occurring because of rising sea levels. I think that's sort of going to be a big issue in South Asia. Any changes we see in the South Asian monsoon, which are not certain, or we don't know how they're going to change, but if the South Asian monsoon starts failing more often, then they're going to have problems. One area where they are going to have problems in South Asia is the glacial melt in the Himalaya, because the Himalayan glaciers provide a steady water resource outside of the monsoon season. Those glaciers are retreating quite significantly. We can already measure that because it's getting warmer. And if they become less stable and many of them disappear, that means that you're going to lose that steady water source during the non-monsoon season, which is going to make it more difficult during that time of the year to provide water for people. So you have all these sort of complex issues, these reverberations of the geophysical changes in the climate affect many human societies because we've developed our societies around a stable climate, around a stable geophysical system. And now that that's changing very rapidly, that means many human societies are going to be affected in many different ways. Here in Australia, we're a largely coastal country. Apart from Canberra, most major cities, I think all major cities are on the coast. And of course, as sea levels rise, as storm surges change, as inland rainfall changes, it's going to have multiple effects on the major population centers in this country as well.
Yeah. I remember reading a couple of years ago that climate change and all the issues that it can bring about, resource scarcity, for instance, could lead to anywhere between, this is a huge range, but 25 million to 1.5 billion people needing to flee from their homes to effectively become refugees to some degree because they just can't live their normal lives in the places they consider home. Do you think that, refugee events, for lack of a better term, at that scale could be on the cards if we don't really bring things under control?
Yes, it could. I mean, they're very large estimates, as you just said. And we don't know for sure how many are going to have to move, have to migrate. What I will say for certain is that migration is already occurring. Much of it is occurring internally. And the example I gave of Bangladesh is something I saw in person when I visited Bangladesh about 5 years ago. I went on a tour with a colleague, a Bangladeshi scientist, around Dhaka. And you could see very large numbers of homeless people, families, basically. He said, these are climate refugees from the Delta. So far, it's internal. But once it spills over into India, then you have political problems. So, yes, this is a looming, potentially very large issue. It's a security issue, obviously, for neighboring countries. And certainly where we sit with a lot of Asian countries around us, a lot of vulnerable Asian countries around us, it is definitely a security issue for us in the long term as well.
Yeah, it's very saddening to I guess think about it. I mean, we already have upwards of 70 million refugees as it is, and I don't know if that accounts for the internal refugees. So yeah, it's quite concerning, especially when we have so many people on this planet, and we're getting more and more. A lot of what we've been discussing in these models and these these projections, they're uncertain, right? Like, the nature of these complex systems is that it's hard to predict what the effects of these perturbations could be down the track. And I don't know if that's discussed as widely enough as it really should be when it comes to making decisions about, you could say, prevention. Can you give me an idea about how uncertain our models really are, at least in the long run? Because my thinking is, if the stakes are so high and our models are quite uncertain, as we could already be reaching these tipping points, and we could be off, in a negative way about what the consequences could be in the near future.
Yeah, there's some very important points in there, and it's a pretty complex issue. Most of the models, I think, are all of the big models that are used in the IPCC to project temperatures out to the end of this century, and some of them go beyond, given human emissions, do a very good job of a lot of the geophysics in the climate system that are what we call well-behaved. In other words, as you increase CO2 levels in the atmosphere, a certain fraction of that is taken up by the land and a certain fraction by the ocean. And the models can do that pretty well. What they don't do very well are these tipping points, these highly nonlinear events. They're extremely difficult to predict and to model, and that's why the modelers don't do it. It's not their fault. It's they're dealing with exceptionally complex issues. Let me just give you a quote that sort of puts the whole picture into perspective. A colleague of mine, a Brazilian scientist, Carlos Nobre, who's internationally renowned. He was chair of the World Climate Research Program, so this guy really knows what he's talking about. And he's an expert on the Brazilian Amazon. And he was asked once about, well, when are you guys going to be able to predict when we hit the tipping point for the Amazon forest? And he says, well, the only way we're going to know for sure where that tipping point lies is by tipping it. And he could have added, well, that's not a very intelligent thing to do. So what we're saying is, when we look at a complex system like this, we can give you a reasonable idea of a bracket of where some of these tipping points lie. For example, I think we can say that for the Arctic sea ice, below 1 degree Celsius, you're pretty certain you're not going to tip it. 1.5 and above, you're certain you're going to tip it. Where between 1 and 1.5 is hard to say. We'll never know absolutely for certain. So what I'm saying is, we need to get out of this idea of using models as future, as very certain future scenarios, and that's why they are scenarios. They're not certain futures. And we need to think of them as giving us information on risk profiles. So how much risk do you want to take with your future? We're already saying, and the IPCC is saying very, very clearly, that there is a very big difference in risk between a 1.5 degree rise in global average temperature and a 2 degree rise in global temperature. The other thing that we're learning as the science improves is that when you look at the IPCC reports in the past up to the present, and you look at the so-called burning embers diagram, these are these risk profiles of starting with a low risk at a 1 degree rise and then going up to increasing risk as we go toward 3 or 4 or 5. When you look through time, as science improves, the high-risk area is coming down to lower temperatures, and that's a general trend. So that's encaptured by this statement, is the more we learn about climate change, the riskier it looks. So basically, we will never know for certain where a lot of these phenomena are going to tip or occur, particularly these nonlinear phenomena. So that means that how are you going to make decisions? Well, my response to policymakers is, how much risk do you want to take with your children's future? Because we can give you some risk profiles, and then it will come down to a social/political judgment of to how much risk we want to take. And then that should guide how fast and how deeply we want to get emissions out of our economic and technological systems.
A lot of the, you could say, the political discourse around climate change and I guess the economics of it relates to jobs and costs and this idea that, we're sacrificing the livelihoods of people and that it's actually expensive. But climate change is already costing us, I think, trillions of dollars a year and is likely to cost us even more in the future. And from what I've seen, there's also tremendous economic opportunities that this global energy, that this the necessity of global energy transfer, or what am I? Just the move to transformation. That's it. That it presents. So, could you tell me a bit about what the costs of climate change are? If we can put a dollar, it's hard to put dollar signs on things like rainforests and reefs and all that, but perhaps the dollar figures on costs to infrastructure and what the economic opportunities actually look like as well.
Yeah, I think the best way to do that is to look at, for example, the insurance costs or the lack of getting insurance on your properties along the coast. I can't quote numbers off the top of my head. They rise very, very steeply. One quote I think is pretty good is that the Great Barrier Reef is worth about $5 or $6 billion a year to the Australian tourism industry, and of course that will be lost. Several years ago now, the federal government here did an estimate of costs of infrastructure loss around Australia with a 1.1 degree sea level rise. I think that was somewhere around $200 billion. So they're big ticket items for all this infrastructure that you might potentially lose. I think the best way to look at it is, will we actually be able to have viable societies with a climate that's out of control and going toward 3 or 4 degrees Celsius? And nobody, that's beyond our ability to actually predict and assess. But the risk is there that it's going to be exceptionally hard to keep a society like we have today going with the sort of stresses and impacts that are going to occur with, say, a 3-degree temperature rise. The Australian Academy of Sciences is going to release within a month from now a report on Australia in a 3-degree world, what this looks like based on the present science. And that you just read that and you say, that's a very hard world to live in. And so then the question is something that we scientists can't really answer, which is how resilient is our society? How resilient is our political and social systems? Can we cope with a rapidly changing climate, one that may hit 3 degrees later this century? So, and there's no certain answer to that. Again, it gets back to how much risk do you really want to take with your economic system, your social system, your children's future, the rest of the living planet. How much risk do you really want to take? And that's the question.
The high risk is collapse, just the collapse of our societies, our inability to live as we do now. And I mean, when I hear collapse, I sort of sometimes think of, very dystopian, barren worlds where there's no rule of law. There's, like all of the civilization and the internet, the things that we take for granted are lost. That's potentially on the cards if we don't play our hand, if we don't sort this out.
Well, actually, there are researchers who study collapse and societal collapse in the past, and they define collapse basically as an uncontrolled decline in a society. And I actually have experienced one in my lifetime, so I can tell you a little bit about what it looks like. And that was the collapse of the Soviet Union, which was fairly minor collapse, and it rebuilt reasonably quickly because it became embedded in a globalized system, which it could link into and rebuild. But I was making trips to the Siberian forests to study them with colleagues from Russia in the early 1990s. So I was going there 93, 94, 95. And, of course, that was only a few years after the Soviet Union collapsed, which is around 1989, 1990. So when I flew into Moscow to meet my colleagues, we had great difficulty finding enough food. The shops were bare. People were out on the streets. You could see a lot of people were coming in from the hinterland from Moscow selling produce on the streets. But when we got to Siberia, you really saw what a collapse looked like because there was no real law. There was no operating system, socially stable system there. So every year we went in, my Russian colleagues would have to check and find out who was in control. We flew into usually a center called Krasnoyarsk in eastern Siberia. And year by year, there was a big fight over whether the KGB or the mafia would be in control. And if you went to the wrong hotel, the hotels were controlled by one or the other. Your life was in danger. In fact, we witnessed a murder at a restaurant in one of the hotels in eastern Siberia, mafia murder. We had to be very careful where we went out in the countryside, what was safe and what wasn't safe. That's what collapse looks like. Now, Russia has pulled out of that, fortunately, but there was a decade or so where there was not much control in that system. So that's what a collapse looks like. It's dangerous. It's hard to get food. That's what some parts of the world may look like if we don't get this under control.
Yeah, and that's one country or region that was sort of kept up, held up by this network of other nations, right? It wasn't a global scenario; it was just happening in that isolated instance, and it wasn't. It was social collapse rather than like what we may experience down the track is the collapse of systems that our societies actually depend upon. So that collapse happened up here, but the collapse that we might be seeing is the ecosystems and everything that really make our livelihoods possible. And we're going to see that potentially across the planet if we don't get our shit together.
Well, that's one of the worst. That's one of the worst case scenarios when you look at the various scenarios. And it really does raise the issue of how adaptable and how resilient are we as an increasingly globalized society. Most of the scenarios look at the most vulnerable parts of the world, Africa obviously being one, parts of South Asia being another one, and so on. Could they tip the global system into collapse? We don't know. Again, there are just as many uncertainties around that as there are around how the biogeophysical system is going to unravel as climate change accelerates. So it's an important topic, I think, to study, to say where are the most vulnerable parts of the human part of the Earth system, and can this sort of contagion, can this occur? Can you get a domino effect with collapsing human societies, and how far will that go? How resilient are the European, North American cultures? Interesting questions. But I think one of the things that I find slightly unnerving is that there is a taboo that is really out there quite strongly about you cannot talk about collapse. This is too depressing. We don't even want to think about it. But having seen what I've seen in the Soviet Union or the ex-Soviet Union, you actually have to think about it and plan for it so that you minimize the impact as parts of the social system become untenable because of climate change and its impacts. We actually need to look at this and say, how best do we prepare for a worst case scenario if this does actually eventuate?
Yeah, and just the coronavirus made it very clear how interconnected and interdependent our societies really are. If a collapse happens in, or something like a collapse happens in certain areas or certain countries that provide lots of goods and resources for other countries, this interconnectivity could actually be quite a problem. I mean, I think with China at the start of the coronavirus, a lot of businesses just couldn't function because they couldn't get their stuff shipped in from China.
That's right.
And we might not see that. I don't know what the deal was with food and, more important resources, though I do think that a lot of our, like at least in Australia, a lot of the chemicals needed for water treatment, I could be completely wrong here, but I think some of the chemicals needed for water treatment we couldn't produce internally, and we had to ship in from the likes of China or other countries. So we can't exist in isolation, at least not the way our societies are structured at the moment. This talk of collapse in nation states and whether or not one country could push us over makes me think of the fact that we have this reigning principle of sovereignty on Earth, right? That nation states are free from interference and that they have supreme authority over, their territory. And in a world where we are faced with such consequences, the idea that one country, if they choose not to abide by climate change guidelines or regulations, the fact that they could potentially tip us over, I think it's a big cause for concern, at least to me. And I'm wondering, but this just might be your personal opinion, or perhaps there's, I don't know how much research has been done or investigation has been done around this, but how possible is it for a world of individual nation states to actually come together to try to combat a global challenge like the one we're facing?
Well, that is the key question, I think. And there are some innovative ideas out there. So far, everything we've tried through the UN system, for example, really has not succeeded. If you look at an emission curve, it's going up at an increasing rate. In other words, it's accelerating. And there have only been a couple of blips in it. One was the global financial crisis. Another blip will be COVID. Because if you actually look at December, when economies were coming out of lockdown, the global emissions for December 2020 were 2% higher from the energy sector than they were in 2019. So already the bounce back from COVID can be seen in increasing emissions. So that's the concern. Now, how do we deal with this politically? As you said, we're a bunch of nation states that economically are increasingly intertwined, but we still seem to fight politically amongst ourselves. One of the most innovative ideas comes from a Portuguese legal expert named Paulo Magalhães, and he is proposing that we need a treaty that recognizes the Earth system, not the Earth, but the Earth system. He calls it the common home for humanity. In other words, it's the software of the planet that's so important, not the territory, the hardware. Because if you look at, we have a territory, we have coastal areas that we claim, the 7 mile or whatever it is, and then the 200-mile economic zone and so on. And you can divvy up Earth, and you can see a map of Earth, and there are bits of the central oceans that are the last bit of territory which is not claimed by a human state. But he's saying we need to legally recognize the software, the Earth system, as the common heritage of all of humanity. And he says legally there are precedents. A good example of this is copyright. Okay? So if you look at a book, I can pull down a book here. That's a physical thing. It weighs a certain amount. It has paper, has ink on the paper. That's the physical book. That's the equivalent of a territory of a country. Okay? But the real value is the interpretation of the symbols in that book, which goes in there. It's intangible, but that's the entire value. But that's why you have copyright, so that when a person writes a book, he or she gets legal recognition of the interpretation of the physical book, not the physical book, the interpretation of it. So the analogy is the real thing that's important for the Earth is the Earth system, the intangible circulation systems, the intangible energy flows, all these things that together make a habitable planet. And there's no legal recognition for that. Brazil says it has legal control over the Amazon, but the Amazon's a key part of the functioning of the Earth system, and so on. So he thinks that if we can get a treaty that recognizes the Earth system, and countries are penalized for damaging the Earth system and are rewarded for restoring and respecting the Earth system, we could develop a different economy that would be robust. It could lead to well-being, but it would intrinsically lead to a stable Earth system, and we don't have that. So that's one idea. I mean, there are other ideas out there, but we need to understand that we need to recognize and we need to protect the system, not just the physical planet, but the system that provides life, the life support system for us.
Yeah, nature doesn't give a damn about the lines we draw on maps.
Absolutely not. Nor do the flows of carbon, nitrogen, phosphorus, energy. They do not respect those whatsoever.
Yeah, and it's funny that, some of us are so tied to the countries to which we, belong, but countries are a new invention. There have been hundreds. They're created and destroyed with the flick of a pen. They're not as real as I think some of us really think of them to be. And it's just thinking about, Australia. Some people, I think there's a lot of patriotic people in Australia, but when something like State of Origin comes around, that patriotism is put aside. State of Origin being the competition in rugby league between New South Wales and Queensland, just for those who aren't aware. When that happens, it's war.
War.
Yeah. But then after that, then Australia plays in the Rugby World Cup or whatever, and we're all pals. So we can kind of shift these tribal affiliations depending on the context, and to live in a world where this place that you're born in that has just been given this label, the fact that can have such an impact on the opportunities you're afforded in life is something that I think we really need to just put behind us and kind of accept that we are this global species and that we all laugh, we all, get on, to a certain degree. But I don't want to do away with countries, right? I don't want us to, we can keep our national heritage and be proud of that, but maybe just put the guns down or...
Absolutely. Yeah, we have to learn to control the violent, aggressive side that we definitely have as a species, and do exactly what you say. I recall I lived in Fiji for a year, and speaking of rugby, wasn't rugby league, it was rugby union. There was a really interesting match between the Fijians and the Maori All Blacks. So these are the All Blacks from New Zealand, but they're all the Maoris. And to watch them play, talk about a fast, hard-hitting match. But as soon as it was over, they were off to the pub in Lautoka, all of them together, just drinking and carrying on and laughing about being islanders, So that's the model, is that we can compete and we can do all this, but ultimately we have to be common stewards of this planet together, no matter what the color of our skin, our ancestry, our language is. We are all the same species, and we have to learn to do that. And we have to celebrate our differences. Absolutely. It'd be a pretty boring world if we were all just homogeneous. It just wouldn't work.
Thank goodness for the differences, because it means that
and we need to respect the differences.
Yeah. I mean, the globalization, and what I mean by that is just the sharing of cultures across borders, not really the homogenization of everything. I want to maintain that diversity, because it means that I can go down the street and I can have Thai food, I can have sushi, I can have the blend of all these things in wonderful ways. It's marvelous. And of course the social, the cultural events as well. Hari Raya, Deepavali, Chinese New Year, Christmas. There's so much value to take out of that. So when it comes to reducing emissions, a lot of us, people are told that they need to, if you care about the environment, it makes sense to go vegan. You should try to avoid driving cars. There's a lot of onus, I think, placed on individuals. And I'm curious about how much of climate emissions come from aggregate individual actions versus the systems in which we inhabit.
It's hard to separate those two, because a lot of our actions are defined to some extent, to a large extent, by the system we're in. Because I'm an earth system scientist, I tend to think about systems rather than individuals, and it's definitely system level change that we need. A simple example would be here in Canberra, where we're now 100% renewable in terms of our electricity sector. So basically what we decided in 2011 was by 2020, we would pay for and install in the Southeast Australian grid the equivalent of all the electricity we use in the form of renewables. So I think all the solar is actually here in the ACT. It's at the edges of Canberra, but of course wind isn't. We went where the wind was good, so we've got some wind farms in Victoria and South Australia, but they're in the grid that we use. So basically the amount of electricity that Canberrans use today, we paid for that equivalent amount of renewables and put it into the grid. So that means that individuals, although a lot of individuals still have rooftop solar, I live in an apartment in the center of Canberra. I don't have rooftop solar, but I feel pretty good that the power that's generating My computer today, as we're talking, comes from the Southeast Australian grid. We've done our fair share here in Canberra by paying for putting in renewables to that extent. Now we are trying to get carbon out of our transport system. A lot of buses we buy will be electric. We're extending a light rail system which runs on electricity, renewables. We're putting in electric vehicle charging stations for electric cars. We're really promoting active transport, cycling, walking, and so on. So you can do it. But the thing that I think what I really like about what the ACT government is doing, it's systemic change. And as individuals, you can play a part in that. But what it means is, for example, when you turn on your electricity at home, whether it's cooking and heating, you don't have to think about, am I doing my share? Am I putting a solar panel up the top? No, you're in Canberra, and the system that you are drawing your electricity from is renewable. So we need systemic change. I think that's what we really need to focus on.
Yeah, I think trying to put the responsibility on people is, I think, unfair as well. We're just, hairless apes, to put it one way, and we can't just change our behaviors overnight, and to expect everyone to do that to such levels, I think it's not really fair. Some people need to drive cars to go to work, or they've got to do, all sorts of things. And I think the move to going more vegan, I think, is advisable, just because of the amount of the planet that we're dedicating to livestock. But I'm hoping for lab grown meat. I think I could do a bit of good on that front.
Yeah, I've had some very good vegan burgers in other parts of the world, and now here in Australia too. I think the other thing about going vegan, of course, is respect for the other forms of life that we are exploiting. Yeah. By having meat-based diets. I think that's an ethical issue, which I think is also important, as well as the emission.
Yeah, for sure. There's that. I don't know what the term to refer to it as, but you're kind of blinded. We have moral blind spots depending on the culture, like the age in which we're born. And it's said that, in 100 years, we may look at how we treat livestock of today in factory farms and all that, as it's like basically slavery. It's like what slavery is to us. In 100 years, the treatment of factory farmed animals, it'll basically be the equivalent, and I can definitely see that being the case. Yeah. So this talk of systemic change, we need to change our entire way of producing energy or getting energy, and there's various ways of doing that. There's wind, solar, geothermal, tidal, and I think nuclear has been there for a while, and it's obviously attracted some tremendous criticism because of the danger of we haven't got nuclear weapons, and we've had Fukushima and Chernobyl. But I'm curious, what are your what's your take on nuclear energy?
I think it's probably unnecessary. You mentioned some of the dangers. Safety regulations are improving, but it's also very costly. So I think from an economic point of view, as well as from a risk point of view, it's simply being outcompeted by the renewables. So solar is exceptionally cheap now. Wind has dropped enormously in price. We know how to firm them, as they call it, which means when the sun isn't shining or the wind isn't blowing, we need power. So you need storage systems, but we're learning how to do that. Pumped hydro has been around for quite a while. Battery technology is changing enormously quickly as well. And interestingly, you can use clever grid technology to do that too. One of the things, as we go to electric vehicles in Canberra, we're going to use those in networks as batteries. So you can store, when the sun's really shining, you got excess energy, you can charge up thousands of cars around Canberra. So you don't need, when you want to run them, you don't need to take that off the grid at the time you're running them. So, and you can use some clever technology software to manage that sort of system. So I think the technologies are changing enormously quickly. Economics is swinging very strongly in favor of renewables. I think the next big breakthrough is, and it's just on the doorstep, is going to be hydrogen as a carrier of renewable energy. and that can be used in manufacturing processes and in transport. So I think the opportunities now are arising at a speed we could hardly imagine a decade ago.
Yeah, and we are well placed to take advantage of that. By that I mean Australia.
Absolutely.
I think we are an energy exporter. And we have been for a while, but that's with fossil fuels. But there's no reason why we can't be an energy exporter with renewables. And I feel like we could be bungling this opportunity because we aren't really investing as much as we need to be. At least that's what it seems like to my somewhat ignorant eyes. I mean, we could just be setting up solar farms the size of cities and then shipping that energy off to Southeast Asia or PNG and investing in this hydrogen technology because I think we're world leaders. We've got, I think CSIRO has done some really good work around hydrogen.
Yeah, we're certainly world leaders in solar. I think we're actually one of the top countries in solar technologies and rolling them out. And you're right, there are huge opportunities with solar-generated hydrogen. A couple of years ago, I was at a meeting in Singapore, and we had a private session offline with some of the senior Singapore government people. They are very keen to go 100% renewable in Singapore, but they can't do it because they have a small territory. So they don't have enough room for solar and wind. And they were very clear that they would love to import renewably generated hydrogen into Singapore. Well, that's not too far away from Australia. We could actually do that, or perhaps even with underwater cables, export electricity itself into Southeast Asia. So there are huge opportunities, and the Southeast Asians are absolutely thirsty to get to renewable as fast as they can. Singapore has a huge vested interest in trying to slow sea level rise for obvious reasons. And so it's in their self-interest, and they recognize that to get carbon out of their systems as fast as they can. You're right. We are positioned to be a powerhouse in our region, and it's one of the fastest growing regions of the world. But the politics within Australia is just not there yet. That's the big roadblock.
Yeah. So we've spoken a bit about reducing emissions and how that's necessary. But there are also some other solutions that we can use in combination with reducing our emissions. One is just taking carbon out of the atmosphere, and the other are some large-scale geoengineering projects. I think one of them is solar geoengineering. I can't remember the name, but basically reducing the amount of sunlight that comes into Earth. Do you have any thoughts on those large-scale interventions?
Yeah, the first thought I would have is to separate the two very clearly. Drawing down CO2 is reducing pressure on the Earth system. And you can do that by regenerating forests. I'm not at all in favor of fast-growing plantations. It may give you, in short term, faster carbon uptake, but it's a pretty well-known fact that if you want to maximize carbon storage, you regenerate complex ecosystems. The ones that were there are there because they maximize carbon storage. And you really work on carbon in soil, where it tends to be longer lived and more stable, and it's better for soil condition to bring a lot more carbon material into the soils, soil organic matter, as we call it.
Could we just stay on this point? So what you're saying is that regenerating complex ecosystems is one of the best ways in which we can draw carbon out of the atmosphere.
Yeah. Now, that's not going to solve the whole problem because we have a massive amount of carbon in the atmosphere. We can't get it all down there, but it's going to help us, and it needs to be done because it has multiple benefits in terms of better agriculture, restoring ecosystems, and so on. And so I much prefer that compared to fast-growing plantations.
Yeah. And what did you say won't work too well? Just growing like rapid vegetation?
Yeah. Fast-growing forests are vulnerable to insect attacks, fires. They're more vulnerable, less resilient than complex ecosystems. They tend to draw down carbon initially faster, but the carbon is less stable in the longer term, and you actually have more carbon stored in the longer term by complex ecosystems than by fast-growing plantations. That's one point. The second point I want to make, that's one of the techniques under the umbrella of drawdown, drawing CO2 down from the atmosphere. And there are similar techniques that may be used in the ocean with seaweed and so on. But I want to very carefully distinguish that which is taking pressure off the Earth system from geoengineering, which is trying to fiddle with the Earth system as a whole, a complex system. One of the common ones you mentioned is to try to intercept incoming solar radiation. You can do that by putting particles in the air, and of course aerosols in the form of smog, which we already have, actually do scatter incoming solar radiation, and in fact can cool the climate. So we estimate that probably maybe half a degree of warming that's already in the system is being masked by pollution today. So this isn't deliberate emission of aerosols. This is aerosols from air pollution. And they indeed, in general, cool the climate. But the problem there is that if you do this on a big scale, we do not yet have the complex models that we need to understand how this is going to affect the Earth system. It's definitely going to change rainfall patterns in ways that probably we don't understand. It's going to change atmospheric circulation for sure. Could change ocean circulation as well by changing the distribution of incoming heat to the surface ocean. None of this we actually understand well enough to be able to predict what's going to happen if we try massive geoengineering, i.e. by continuously pumping aerosols into the atmosphere. You can easily say country X is going to attack country Y because it's stolen its rainfall by putting aerosols in the atmosphere and changing rainfall patterns, changing monsoon patterns. We simply don't know this. And in principle, what you are doing is you are trying to modify the complex system itself, the Earth system, rather than taking the pressure off the Earth system. So I would never lump geoengineering in the same basket as drawdown. So I think that's one very important distinction we need to make.
Yeah. I didn't mean to. I just thought of these as two various solutions.
Yeah, and they often are talked about together.
Okay.
So I definitely want to separate.
Yeah. The more I learn about, like, I'm not a complex system scientist at all. I'm just a novice. But the more I learn about them, the more discussions of these large-scale interventions scare me. Just the idea of just trying to do something at this level where we don't really know what the consequences could be. I mean, one potential, like one corollary, I guess, example of something that could be, compared to this is, if it went wrong, it'd be like a supervolcano blanketing the planet in ash and then causing widespread destruction and just a die-off. I'm just very hesitant about these large scale interventions when we just really don't know much about how these things, how something as complex as planet Earth, this living system, really is.
No, that's right.
Do you know of any promising carbon capture technologies or solutions that are being proposed aside from reforestation and the development of complex biospheres or ecosystems?
I don't think there are any that are close to being commercially viable yet at large scale. There's a so-called CCS, carbon capture and storage, which is an industrial process that tries to capture CO2 from smokestacks and from the source. You can do that perhaps also from gas wells as you get some outgassing of CO2 during the mining process. In fact, one of the pilot plants is out in Western Australia, the Gorgon gas field is attempting carbon capture and storage. It's being used in Norway, but often, interestingly, the original purpose of capturing CO2 and compressing it was actually to pump it back down and get actually more oil out of the oil wells in the North Sea. So
it's quite ironic.
It was used in more fossil fuels. But in fact, in principle, you can do that. But as yet, we do not have the technologies at scale or at cost that can make a dent in this problem.
We don't have the technology in this way of saying technology, but we have life that is, the greatest. Life is full of the greatest technologies we've ever come across. Like a lot of our technologies are just inspired by life. I mean, I see the technologist in me as like, we should put our heads together and really do it. But I think as time will hopefully tell, just rewilding much of the Earth is our best bet. And I mean, I feel like it's the most, like, the ethically right thing to do, to bring more life into this world and to have more complex ecosystems. And because I think one of the most remarkable, wonderful things about the evolution of life across time is that there's this increase in complexity, across millennia, across millions of years, and it regulates the system of Earth itself. Like, there's this Gaia hypothesis. Do you want to talk a bit about the Gaia hypothesis as Earth as a living system?
Yeah, well, the Gaia was one of the early, very important concepts in the development of Earth system science. You could actually go back, if you really want to go back to where Earth system science comes from, it probably comes from indigenous cultures around the world. Australian indigenous culture had a very good idea of systems at various scales. And when you read some of the translations of indigenous knowledge, it shows a system level understanding. But contemporary Earth system science really started in the early 1920s with a Serbian Russian scientist named Vernadsky. And he was the one who started talking about the role of life, just as you said, as not just a passive passenger in the Earth, but as an active player in forming and guiding and controlling even the Earth system. And then, of course, the next big, I think, event in Earth system science was James Lovelock with this Gaia hypothesis in the 1980s. And he really looked at the control theory aspect of saying life isn't just here sort of enjoying itself. It's actually controlling the environment of the planet to make sure it prospers. And, of course, there's a big controversy over how much that really is a controlling factor and so on. But in the end, contemporary Earth system science, and by that I mean from the time of Lovelock onwards, is actually showing that, yes, he is right to an extent that life can control and really modify and maintain certain states of the Earth system. But then you get external forces, be it a big meteorite or huge volcanic eruptions, which really sort of blow life apart a bit for a while, but don't destroy it. And then it has to reform in different ways, and it regains control. And you see this in the history of Earth. So what we're seeing now is the next big explosion, but it's not a volcano and it's not an asteroid strike. It's part of life itself. That is, technological Homo sapiens is acting as a big disruptor to the Earth system. So the question is, how's the Earth system going to respond? And that's a good question. We don't know. But so I think this idea of life being an important player in the Earth system, not a passive spectator, is really, really important. And understanding how Earth is going to respond to this incredible abrupt pressure that humans are putting onto it, well, that's something that science really can't sort out yet. We don't have the science that'll be able to do that.
Yeah. I want to bring the conversation back to the actions that we need to take in order to preserve the planet as we know it. What sort of timelines are we looking at? Because we hear we need to, the Australian government set a goal for 2050, I think, to be carbon neutral. Other countries, I think, what was the Paris Climate Accord again? Was it what was it 2030?
No, they didn't have the Paris Accord called for pledges from countries by 2030, but the overall goal for stabilizing the climate system was keeping global temperature to well below 2 degrees and to make efforts to cap it at 1.5. So the wording was careful. 1.5 wasn't really a temperature target. It was an aspirational target that we should make efforts towards. We're not going to make that, of course, without overshoot. We're going to go towards 2 degrees. But what do we need to do? If you want to keep temperature to well below 2, we need to get to what's called net zero before 2050. 2050 is too late under almost any scenario. So globally, the latest we should really aim for is about 2040. a bit earlier if we can. So then, but to get, whether you still want to stick with 2050 or if you want to go to 2040, the only way you can get to those targets is by doing much more by 2030. So when you look at trajectories and look at cumulative amounts of CO2 emissions for those trajectories, and you look at the temperature target, that tells you that 2030 is really absolutely critical. We have to get substantial emission reductions by then. Globally, I would say we need at least 50%, cut them in half in a decade. That can be done.
So from now, we need to halve it within a decade.
Yeah. And Canberra's done it. We're a small jurisdiction, but we've dropped our emissions, I think, compared to when we started in 2011 by something like 55%. And that was a combination of efficiencies and going 100% renewable. We're unusual because we don't have fossil fuels here in the territory. We don't have any heavy industry. So you can't really say you can use the Canberra model. It's just to say that we've put a good effort in and shown you can get substantial reductions in a decade. For Australia as a whole, it's going to be harder, but it's not impossible. The more you can go beyond 50%, the more likely it is you're going to get to net zero by 2040. Now, when we made our Paris pledge as a country in 2015, the Climate Change Authority actually gave some advice to the Australian government, saying that we should aim for 40 to 60% reduction. I think that was on 2005 levels by 2030. And if you get the midpoint of that, well, that's 50%. But they actually advocated to really do our best to go for 60%. So that's really the sort of thing we need to be aiming at. In fact, if we could even do better, that would be a great step forward. Some people argue that Australia should do more than the global average because we're wealthy and because of our past emissions, we've got a big legacy that we have to try to account for.
Yeah, I remember one of the politicians saying like, "Oh, we only contribute, 1% to the global emissions, and there are other countries that contribute way more." And it's like, yeah, but we're a country of 25 million people.
Yeah. I actually I was in a court case on a coal mine, and that argument was used saying that Australia only contributes 1.2%. It's too small to matter. Why do we worry about the next coal mine? So I gave an analogy. I said, I pay tax to the Australian Tax Office every year, income tax. My tax is much less than 1.2%. It's 0.000001%. So I turned to the attorney for the coal mine and said, I want you to co-sign a letter. I'm going to write a letter to the Australian Tax Office to say, I will no longer pay my income tax because it's too small to matter. And I'll quote how much my percentage is. And I would like you to countersign saying that this is the argument you think is appropriate for doing a fair share. And I said, I can guarantee you that the Australian Tax Office will not think very kindly of such a letter. And so the attorney sort of shrunk back a bit, saying like, you could sort of realize the fallacy in this argument. Everyone has to do their fair share globally. China has to do much more than we do. US has to do much more than we do. We have to do much more than Nigeria or Ghana or Bangladesh because we emit a lot more. Every country has to do its fair share.
Yeah.
That's my argument.
And I just want to stress again that this isn't just about doing our fair share and doing a good thing that's going to harm us, but it's actually such a great opportunity as well. We could be, we already are leaders. We have the technology. We have the, we're a relatively entrepreneurial nation. We have the land. We have the resources. There's no reason why we can't really turn this in our favor.
Absolutely. And when you look at some analogies, people say, well, we can't do it this fast. You look at World War II. Economies were made over. Technologies were made over in 5 to 10 years because of World War II. And it was hugely disruptive, and economies went down for a while. But coming out of that is when the global system really took off, and economies took off, and technologies took off. And my country of origin, the United States, is one of the biggest beneficiaries of that. Coming out of World War II, it completely remade its economy. It saw the opportunities. The U.S. took off and became a global power, mainly after the Second World War. In this region, Australia could become an absolute powerhouse in terms of technologies, in terms of knowledge, and in terms of export of all sorts of the new economy into Asia. As you said, there is an enormous opportunity, but maybe what we need is a very disruptive decade that disrupts the present Australian political and economic system, but rebuilds one that is going to be a powerhouse going forward. All the seeds are there. The entrepreneurs are there. The technologies are there. The connections with other countries are growing. We need to break the system that's here now and build the new one as fast as we can.
Yeah, I love that term powerhouse as well. It's just, it's perfect.
We could be. That's absolutely feasible.
Yeah. What was I about to say? Anyway, I've had this idea for a while that just to focus on Australia again, but I think it's true for a lot of other countries. But being anti-climate action is un-Australian because we love nature, we love the outdoors, the surfing, the camping, snorkeling, all of that, and we love sport. You know, we love our summer sport, and if we do not take the action necessary, then all of these are under threat. So you could kind of frame being against climate action as actually being un-Australian, and I think that could have really that could cause quite a bit of cognitive dissonance in those that are more conservative, because they are more likely to identify as being patriotic and pro-Australia, and just saying, well, your politics where this is concerned is actually un-Australian. I think it could cause a bit of strife, a bit of anger, but I think it could actually have some sort of effect.
Yeah, look, that's a really interesting point. And I was just going to mention that. It's a perfect opportunity for me to put a plug in for an upcoming Climate Council report, which is on climate change and sport. And I must admit, I was amazed when I read it myself. I wasn't the lead author. I didn't contribute much at all. But the impact already of climate change on Australian sport was far greater than I thought. We know a fair bit about the Australian Open, the tennis tournament and so on, but it's affecting rugby, it's affecting cricket, it's affecting surfing, it's affecting personal, individual sport, as well as the iconic sports that we all go out and watch. That could be a game changer. I agree. And this is it's a major report. It's a well-researched report, but it really shows how much already climate change is affecting our sporting life and what the risks are for the future. So I think that's a really good point.
Yeah. And just on the tennis in Melbourne, the Australian Open, they have court temperatures in at 40 degrees or something, right?
Well, close to 50 on
the court. So, I mean, there's being Australian, but imagine coming from, some cold country in Europe and then having to play in a sauna. I think that gives us the advantage, as Australia, like the Australian tennis players. I think we have the advantage where that's concerned.
But there are quite a few instances now of players retiring from heat stress in the Australian Open, or at least asking for longer breaks to rehydrate and so on. It is already an issue, and it's a serious issue. But this report talks about other sport too that's being affected by climate change.
Yeah, just on that point on heat stress, that kills quite a lot of people the worldwide, and we don't really hear about it so much. But deaths due to just overheating is quite common, and it's of course going to become increasingly common as the world heats up. And it's not like you can just put the air conditioning on, right? Because when it's that hot, everyone's putting their conditioning on. There's increased load on the network, on the power grid. Things might not be able to function that well at those temperatures. So we could really see a lot more people dying just due to things just being too hot.
That's right, and there's already been some good work on that. So the most vulnerable people here in Australia and probably globally are obviously elderly people or people with pre-existing medical conditions, but also infants and young children. And the other area that might be a bit surprising is outdoor workers who are still in the prime of their life, but are working in exceptionally hot conditions. We actually see some mortality statistics for them as well. But you're right, heat stress is one of the biggest killers in terms of climate-related impacts.
Yeah. we're drawing close to the end of our time, so I think before we wrap up, could you talk to me about? Actually, I remember what I was going to say before. I watched one of your talks that I think you gave last year, and you showed a little picture, and it was, I can't remember it verbatim, but it basically said that we were told that we couldn't just stop doing everything and, wind down our economies, to combat climate change. We just can't do it. And then God said, here's the coronavirus. Here's a test.
Yes, that's right.
Yeah.
So when you face an immediate emergency like the coronavirus, and it's obviously in your face, it's your health, and it's immediate, then you react, and suddenly things that you couldn't do before you do, like Job Keeper and Job Seeker and all sorts of other things we did. And as a country, we've done pretty well on dealing with the coronavirus compared to most other places. Another example, of course, is in World War II, where economies completely reorganized, restructured, sort of at lightning speed to deal with a threat. The problem with climate change is a couple-fold. One is we are the enemy, at least the way we live is the enemy. And it's what some people call a long fuse Big Bang problem, because the emissions we're doing now are putting in place, locking in damages for our children. And that time scale is hard for humans to deal with. When it's immediate, like COVID or big war, yeah, we can really deal with that. And we do quite well. We're a good species for that. But when it's a long fuse Big Bang problem, and we are, in fact, the problem, that's really hard to deal with. So
yeah, and on the topic of just bringing it to how our technological capacities can change so rapidly, I spoke to an innovation economist the other day, and he said that when the coronavirus hit, we basically developed a handful of new ways of creating vaccines
yes.
And there was, I think there was a bit of stagnation in vaccine development science, however you want to characterize it. And the coronavirus hit, and we now have all these new ways of developing vaccines that we didn't have before. So if we can take this and apply it to things that are more climate related, I mean, there's a lot of brilliant people out there who I think if they put their efforts towards it, and I'm not saying there aren't too many people. I'm not saying there aren't lots of people doing that right now, but when there's more of a global concerted effort, who knows what we can do?
Yep, absolutely. I agree with that.
Yeah. So in this talk that I was alluding to before, there's a picture, and it's a graph of sorts. With one axis being time, and it's Earth traveling down this landscape,
Yes.
and it's in a stable situation, but there is a risk of it veering off into what's called a hothouse Earth. Is that right? Yeah. So what is that scenario, and why can't we? Why is it hard to escape once we're in there? Because I think that's called like an attractor. I think there's something that's attracting us towards it. And I think it's got something to do with these positive feedback loops. Is that right?
That's correct. So it's called an attractor in complex system jargon. It's not very attractive at all, but it's called an attractor because it's pulled in that direction. So that cartoon-like landscape had the Earth poised at a fork in the pathways, a fork in the road between two possible futures. And one of them is what we call stabilized Earth, which is if we do get climate change under control this decade, if we do rewild and regenerate the biosphere and so on, if we do solve a lot of our social issues, our equity issues and so on, we could generate what we call a stabilized Earth, which would have a stabilized environment, much more well-functioning societies, etc. But the other one, which is an attractor, and that's because of these feedbacks, things like the melting Arctic sea ice, the Amazon forest and so on, once you get enough of these tipping points, they could act like a row of dominoes where one could influence the next, And if we get too many of those tipping, then the Earth itself will be irreversibly on that pathway. We won't be able to stop it. So that's the fork in the road. We don't know where that lies, and that gets back to our discussion on risk. We never will know for certain where that lies. So the question is, how much risk do you want to take? But once we get on that pathway, and realize that it'll probably be too late. we're stuck with hothouse Earth, which is going to be probably a catastrophic outcome for many societies around the planet.
And what I really liked about that talk is the discussion of inequality and how inequality isn't just about, I guess, social outcomes, but it's also directly related to climate change itself.
And that's because it's part of the same system. So the point is this system, this socioeconomic, globalized socioeconomic system that we've got is, first of all, it's generating an enormous amount of wealth. It is bringing a lot of people out of poverty in certain parts of the world. So there are good sides of it that a lot of people will put forward. But what's happening now is that the side effects, which 40 years ago were fairly small, are now sort of overwhelming the positive benefits of the system. And what are these? Well, it's growing inequalities. And if you look at what that is starting to mean, if you look at, say, people who are now malnourished around the world, that's shrunk. It's now something like, well, it's less than 1 billion out of nearly 8 billion people. But the people who are obese, overweight, and are suffering micronutrient problems in wealthy countries is now between 2 and 3 billion, far greater than malnourished people. So we are now growing more problems in the wealthy part of the world than we're solving elsewhere. So we're now going toward the 6th great extinction event. We are liquidating the biosphere at an accelerating rate. That's what our economic system is doing. We are pouring greenhouse gases into the atmosphere at an accelerating rate, and we're destabilizing the climate. So basically, we've built a system that has been very good at generating wealth for humans, but it's now eating away and eroding our own life support system. So that's the problem. So I like to look at this as a neurosystem scientist as a systemic problem. The same system that is pumping massive amounts of CO2 into the atmosphere is growing inequalities, leading to social problems, leading to bad social impacts. So it's the system we need to change. That's the one key message I think I want to get across is this isn't the problem of individuals doing the right thing. This is the problem of individuals getting out on the streets, writing to their political representatives, change the system and change it fast. That's what we have to do.
Yeah. Well, Will, thank you very much for taking the time to have this conversation. If the people listening out there want to follow more of your work or just be kept abreast of the things you're working on and just other developments or projects in this general area, where would you direct them online?
I would direct them to the Climate Council website, climatecouncil.org. I think it's climatecouncil.au. I'm not exactly sure what it is myself.
Yeah, I'll link it.
Google. Oh, yeah, you get it. Yeah, because my work on climate change is really through the Climate Council. And there are a lot of other good people here in Australia working on that. So you can get the latest on the science, on the solutions, on what's happening to the biosphere with climate change and so on through that. That's probably the best way to keep up with what I spend a lot of my time on these days.
Okay, wonderful. Well, I'll share that in the show notes. Well, Will, thank you again, and we'll talk soon.
Thank you.